Welcome back. We are solving Advent of Code Day 6. Wait for it. The very quickly brings you across island. After asking around, you discover that there is indeed normally a large pile of sand somewhere near here, but you don't see anything besides lots of water and the small island where the ferry has stopped. As you try to figure out what to do next, you notice a poster on a wall near the ferry dock. Boat races open to the public. Grand prize is an all expenses paid trip to desert island. That must be where the sand comes from. Best of all, the boat races are starting in just a few minutes. You manage to sign up as a competitor in the boat races just in time. The organizer explains that it's not really a traditional race. Instead, you will get a fixed amount of time during which your boat has to travel as far as it can, and you win if your boat goes the farthest. As part of signing up, you get a sheet of paper, your puzzle input, that lists the time allowed for each race and also the best distance ever recorded in that race. To guarantee you win the grand prize, you need to make sure you go farther in each race than the current record holder. Okay, the organizer brings you over to the area where the boat races are held. The boats are much smaller than you expected. They are actually toy boats, each with a big button on top. Holding down the button charges the boat, and releasing the button allows the boat to move. Boats move faster if their button was held longer, but time spent holding the button counts against the total race time. You can only hold the button at the start of the race, and boats don't move until the button is released. Time distance. This document describes 3 races. The first race lasts 7 milliseconds. The record distance in this race is 9. Okay, 3 races in 3 columns. Second race lasts 15 milliseconds, and the record distance is this. Your toy boat has a starting speed of 0. For each whole millisecond you spend at the beginning of the race holding down the button, the boat speed increases by 1 millimeter, okay, by 1 unit. So because the first race lasts 7 milliseconds, you only have a few options. This is the first race. Don't hold the button at all, that is, hold it for 0 milliseconds at the start of the race. The boat won't move. It will have traveled 0 millimeters by the end of the race. Fine, this is first case. Hold it for 1 millisecond, then the boat will travel at a speed of that for 6 milliseconds. Okay, we need to fix it for some time, then release it, and for the rest of the time it will move with that speed. So we hold the button for 1 millisecond, then the boat will travel at a speed of 1 millimeter per millisecond for 6 milliseconds. So this was 7 milliseconds race, but we hold the button for 1 millisecond, and the rest of the time, that is 6 milliseconds, we get that speed. Reaching a total distance of that, hold the button for 2, 3. If there is a 2, then this will be the speed, and the rest of the time that is remaining will be 5. So 5 multiplied by 2, 10. Okay, understood. That's the entire. So there are 8 possible choices, 0 till the total time. That's the entire duration of the race. You never let go of the button. The boat can't move until you let go of the button. Please make sure you let go of the button so the boat move. In this case, the distance time remaining will be 0, and 0 multiplied by any speed would essentially become 0. Since the current record for this race is 9 millimeters, there are actually 4 different ways you could win. You could hold the button for, okay, for all the possible choices. There are these choices for which we win the race. Record is 9. Fine. In the second race, you could hold the button for at least 4 milliseconds and at most 11 milliseconds and beat the record, and a total of 8 different ways to win. In the third race, you could hold the button for at least this and no more than 19 total of this. To see how much margin of error you have, determine the number of ways you can beat the record in each race. In this example, we find that the number of ways to 4, 8 and 9, which means the product is the answer, and determine the number of ways you could beat the record in each race. What do you get if you multiply all of these numbers together? Fine, let's hope this is the okay. I think the time distance are fairly small. We don't know what part 2 brings. So last day 5 was really tough. So let's see what the solution brings. Use 2023, create d5 d6. Sol.cpp. Let's first take in 1. Let's also take in 2. We don't need this, don't need this. And what I can do is, let's say there are 4 races. Here there are 3 races. Don't need this. This. Done for this. Done. So first is the time, total time, and the distance. Okay, fine. So .cpp. Let this, that this, and total number of races. Then we have, let's say, vector of times distance. Let's say t and d for simplicity. T and d. Let's do one thing. T dot resize n, d dot resize n for int reference of value. We get this f t r t. Actually, okay, this would be the input. Next, we need to go over all of them. Say this is id all the way up to n. We will try to hold it for so this race has time equals to t of id, and we can hold it for 0, 1, 2 all the way up to t, so t plus 1 here. So this exclude the rightmost. We'll hold it for that duration, and the rest of the duration remaining t would be t minus the time for which we have hold. This would be the speed. This would be the speed, and the time remaining in this case would be so velocity is distance upon time. So distance T remaining in this case would be, wait, we have traveled 0 millimeters by the end of the race. Seven minus, so this is speed, hold. No, this should be T remain, I guess. T remain should be this, and speed should be hold. And the distance that we have gone for this particular case would be, let's say, X. This thing. And do we have to beat it strictly? Here the best answer is 9, and I don't think 9 is allowed or not. The current record for this race is 9 meters. There are actually 4 different. You could win. You could hold the button for this. Let's see what they have said about winning. You will get a fixed amount of time during which your boat has to travel as far as it can, and you win if your boat goes the farthest. Okay, to guarantee you win the grand prize, you need to make sure you go farther in each race than the current record holder. Okay, so if X is greater than D of ID, this is one possible way for this race. And the final answer is the product, right? Let's initialize it with 1. After finding out the number of ways for this particular race, we multiply it by the number of ways and the answer. We don't have, what is the answer for first case? 28. Let's run. Test 1 seems correct, and since we don't know the answer for test 2, let's check this. Perfect. Let's move on to part 2. As the race is about to start, let me save this file first. Copy sol.cpp, sol part1.cpp. Fine. As the race is about to start, you realize the piece of paper with race times and record distance you got earlier actually just has very bad kerning. I don't know what that is. There is really only one race, even though the spaces between the numbers on each line. So the example from the above means this is the race, and let's say what this concatenates to. So this number would become very large. Instead, this means this. Now you have to figure out how many ways there are to win this single race. In this example, the race lasts for this time, and the record distance you need to beat is this thing. You could hold the button anywhere from List of this milliseconds and beat the record a total of this many ways. One thing to notice here is the number of ways always lie in a contiguous range. Seven 1.5. In this case, is actually like this R1. And this is this. This is of order 10 raised to 12 or 15, I guess. This is 10 raised to 8. We can try all of these, and this distance doesn't matter, right? Because we only need to check what is the possible choices for all of the starting points. So let's try this same approach and check what is the answer. It should be slow, but let's check it anyways. So here it was 71503, and let's try this one. Okay, both of these solutions work. That's cool. But we will try to find out some better solution as well. Let's spend some time investigating that. Okay. So for some fixed T and T, we don't care what is in this array. For now, let's say that we are trying the values for hold in this range. So hold in 0, 1, let's say it is, and this T was of order 10 raised to 6 for the larger part, for the large test case, and this is what we are going to iterate. It is better, it is not that slow of a solution, but let's try to find out if a better solution exists. So for every hold, we are basically trying to we compute the value of x as hold times t minus hold, right? Because we are taking speed is hold, hence this is hold, and t remain is t minus hold. So this is what we are computing for each fixed value in the range 0 to t. Now if we separate this out, hold times t minus hold square, notice that for let's say this equation is in this equation t is constant because t is fixed, and we always take the value of t as whatever is given in the this part. So it was fixed as 71530 for all the possible values for hold, and since it is a constant and this is the variable, so if we represent this in terms of a function, so it would be constant times, so x is the variable, denoting x as, say, f of x. F of x equals to hold is a variable, let's say it is denoted by x. It would be constant, let's say k, multiplied by x minus x square. So y equals to minus x square plus kx. If we try to put this equation in GeoGebra, let's try to figure out what is the graph of that particular function. If it is monotonic, then we can apply binary search as well. So y equals to minus x square plus kx. For now, let's say k is 100 or small value like 2. Right? Y equals to minus x square plus kx. K is constant, let's say 2. Even if we change the constant, the concavity of the function does not change. So even if we take it 100 or 3, everything. So this is a parabola facing downwards on x-axis, and what we need to do is we need to find out the ranges of values of x, which is hold, which lies in range 0 to t, for which this value that we are computing, it is greater than some another constant given in the question, which was d of id. Let's say it is t. So obviously we want this function to be greater than d, and we need to find out for what all values of k is known, d is also known, and we need to know for what all values of x this function is, this equation holds true. So x square minus kx square minus kx plus t is less than 0, right? So if I change this function to this thing, k and d are constant. Perfect. Where is this function? X square. Okay. Where is this function? X is the range of values that we can input, right? If we change this, this shrinks, and changing k shifts that particular range. So we know that x takes values in this range, right? So x takes values in 0 to t. So this function will be and we only have positive values for x. Let's change this equality sign first. T. And we want to find out this is a parabola, and we need to find out for what values of this parabola, for what values of x, integer values, so that the graph lies below the x-axis, so that this we want this equation to be negative. We want this entire thing to be negative, and since this is an upward facing parabola, we want to find out for all what all values of x this what do we call, we will be inputting the values for in this range, and for all of them the equation of parabola is lying below the y-axis, x-axis. That means it is negative. So somehow we need to find out these two intersection points, L and R, and count of integers between them would be the final answer. So let's try some given input only. What was that? 7 and 9. K is 7, right? Yeah, K is 7 and D is 9. So K is 7 and D is 9. For this, the what do we call possible values of x? What were they? They were 2, 3, 4, and 5, right? So as you can see, there are 2, 3, this 2, this 3, this 4, and this 5 are the only integers for which the parabola lies below the x-axis. So somehow we need to find out the leftmost this part. So we will find out the roots of this parabola, equation of parabola. Then there will be two of them. First will give us this range and then this one, and it may be possible that this does not intersect with the x-axis. In that case, no solution is possible. But I hope there is at least one answer, one way, because since we are finding out the product may become negative if we say that there is a constraint for which the parabola does not intersect with the x-axis. So Let's find out the equations, the roots of the parabola. So this for loop will go away. Here t was this, t was d of id. Okay, let's find out the number of ways and then multiply with the answer. To find out the roots, we can say that this is 0. I just want to take the formula as it is, if they are given or not. Okay, that's fine, we can do it. Root is minus b plus minus root of b square minus 4ac, b square minus 4 is 4ac whole divided by 2a. And the other one is minus b plus would be the larger one, this would be the smaller one. So let's say this is minus, first would be, let's compute it in double formats, and then afterwards we can change it to integers. And in this equation a is, so the equation of line is again, so I'm so slow for this, ax square plus bx plus c equals to 0. So a is 1, b is minus k. What is k? I've messed up the variable names, but it's fine. And c is t minus b minus square root down b square minus 4ac. Second root is minus b plus, so it should be double. Let's print them out first to check whether yeah, finding the right roots of the equation. Let me use fixed precision. Fixed precision 5 first. Okay, let's run it. There is only one race. We are solving this for part 2. Why is this root so large? Okay, right. It has to be large because I'm using the part 2 input. What was that again? So on in one, it was 71517, but here it is 71516. So, and this is correct. We are using the next integer from this 13, so it would be 14, but 14 to 71517, but here it is 14 to 71516. So we are off by one. Let's, maybe it is a precision issue. Let's try to increase the precision. 5 change to 10. Check. Okay, 71516. So yeah, that's correct now. And so, as I told, this parabola intersects at some real points which are values of x, which were 13.14 in this case and 71516 point something in that case. So the integers in that range would be the next integer from this would be 14, and the previous integer from the right hand point would be 71516. So that is what is being asked in this question, and the same for the larger input. Let's try to do that now. To do that, what I can do is, since this always gives us a non-properly divisible fraction, so let me convert it into integer for the first part, and for the left one I need to take, wait, for the first root I need to take the next integer, which would be 14. So I will take the integer part 13 and add 1, and for this second root I will simply take the integer value, which would be the floor value 71516. Okay, so L would be integer value of first plus 1, and right would be simply integer value of second, and the count of ways for this particular race would be r minus l plus 1, because count of integers in that particular range, and multiply the answer with base. Perfect. Answer should be 71503. 71503 and 32607,562. Perfect. Okay, and now we have successfully solved this in constant time. In fact, so we only had one race, so n was 1, and we have solved this in literally constant time, no for loops, just simple math. I will keep these comments as it is. Before that, let me what I wanted to do. I'll be back in a minute. Okay. I'll just clean this up and commit on GitHub. You can go over the code. I will try to keep the comments as it is. So this is sol.cpp sol. This is applicable for both of the parts, I guess. So fastest solution, both parts. .cpp. Okay, just a minute. Okay, let's clean this up. I will keep the inputs. No need of this. rm into 1 up to sol. Fine. Is there anything to refactor in this? We don't need sol, right? Because it is the same as the fastest solution. Anything to clean up here? No. Part 2 is same as part 1. Okay, fine. Just keeping it for reference. Remove sol. Add the files in this directory. Commit message as it is. Change day 5 to day 6 and push. That's it for this stream. See you guys tomorrow. Thank you.